All right, welcome future master technicians. Today, we're going to dive deep, really deep, into the brain and the muscles behind the modern engine's spark. We're talking about the electronic ignition system. So if you're still thinking about points and condensers, it's time to clear that out because we're going digital. Let's get right into it. Okay, so first things first. To really get where we are now, you've got to understand where we came from. See, this whole electronic revolution, it all started because we had to solve a really old problem. And that meant saying goodbye to a very old and, let's be honest, a pretty unreliable friend, the mechanical distributor. And this picture just says it all, doesn't it? Look over on the left. That's the old guard, the mechanical distributor. It was a marvel for its time, sure, but it's just packed with all these moving parts, Points, weights, a rotor, a cap, and every single one of them was just waiting for its turn to wear out, corrode, or just plain fail. Now, look to the right. That's our new standard. It's clean, it's computer-controlled, and the best part? Way fewer moving parts. It's built for one thing, precision and reliability. So, you gotta ask, why the big change? Well, let me tell you, this wasn't just a minor update. No way. This was a complete overhaul. See, electronic systems get rid of all those parts that cause the biggest headaches. And what do you get instead? You get a constant, powerful spark, even when the engine is absolutely screaming at high RPMs. The ignition timing, it stays perfectly locked in, and that means less maintenance for the customer, which they love, and way better performance, better fuel economy, and cleaner emissions for everybody. It's a total win-win-win situation. Okay, so with the old distributor out of the picture, who are the new heroes of this story? A whole new team had to step up to the plate. Let's meet the key players. Right at the top of the command chain, we've got the engine control module, the ECM. You really got to think of this thing as the brain of the whole operation. It's the central computer, and it is constantly crunching data, making thousands of decisions every single second, all to figure out the absolute perfect millisecond to fire that spark. Now, I want you to really focus on this next one, the crankshaft position sensor, or CKP. This isn't just a sensor, it's the master sensor. It is the one component the ECM absolutely cannot function without. It's telling the ECM how fast the engine is spinning and the exact position of that crankshaft. So what happens if the sensor fails? Well, the ECM is completely blind. The engine will crank all day long, but you will get absolutely zero spark. Burn this into your brain. It's your number one suspect in any crank no-start diagnosis. And this diagram right here, this really shows you the whole logic in action. You've got sensors for engine speed, load, temperature. Think of them as the system's eyes and ears. They're feeding this constant stream of data to the computer, to the ECM. The ECM takes it all in, processes it, and then sends out the command to the ignition system to create the perfect spark for whatever the engine is doing at that exact moment. So let's follow the journey, right? Let's trace that signal flow from start to finish. We're going to make the invisible visible and see exactly how all these parts work together in this beautiful, perfectly timed dance to create combustion. And you have to remember, all of this happens in the blink of an eye, literally, in milliseconds. So the CKP sensor reports in, the ECM does its complex math, then bam, it commands the ignition module to charge up the coil. The coil takes that little bit of battery voltage and multiplies it into this massive charge. We're talking up to 70,000 volts here. That massive voltage then zips down to the spark plug, jumps the gap, and creates the spark that ignites the air-fuel mixture. It's just an incredibly precise, powerful, and ridiculously fast chain of events. All right, team, enough with the theory. Let's get our hands dirty and move this into the workshop. This is where the rubber meets the road, where we take all this knowledge and turn it into action. This is how we diagnose the problem and get that customer back on the road. Think of this table as your first diagnostic guide. It's your cheat sheet, really. What it does is connect what the driver is actually feeling, the symptom, directly to the most likely culprit in the ignition system. So if the engine cranks but it won't start, what did we just talk about? What's the first thing you check? That's right, the CKP sensor. Or what if you've got a rough idle or a misfire? Maybe it's a single bad coil on plug, or maybe just some moisture got down in the spark plug well and is shorting things out. If you learn these connections, I promise you, it'll save you a ton of time in the bay. Okay, here's a real pro tip for you, one that comes straight from the field. On a distributorless ignition system, a DIS system, that uses what we call waste spark, a single coil often fires two spark plugs at the very same time. So if you pull codes and you see a misfire on cylinders 1 and 4, or maybe 2 and 3, stop. Don't go chasing two separate problems. They share a coil pack, and that single coil pack is almost definitely your point of failure. Look, your most trusted tool in the shop is probably going to be your multimeter. And testing a coil, that's a fundamental skill you have to master. So first step, and this is really important, you have to disconnect it completely from the vehicle's wiring. Then you'll set your meter to measure resistance, which is ohms. You're going to measure the primary resistance across the low voltage terminals, and then you'll measure the secondary resistance on the high voltage side. And the last most critical step of all, you have to compare your readings to the manufacturer's specifications. So what kind of numbers are we even looking for? Well, generally speaking, the primary winding is going to have a very low resistance, maybe around 1 ohm. But the secondary winding, that's going to be much, much higher. We're talking thousands of ohms, or kilo ohms. Now, these are just typical ranges, right? If your meter reads infinity or OL, that means you've got an open circuit inside. If it reads 0, that's a short. Either way, if your numbers are way outside the manufacturer's spec, that coil is toast. Time for a new one. Okay, before we finish up, we need to talk about what is single-handedly the most important topic of all, how to do all of this safely. Because listen, a mistake here isn't just dangerous. It can be incredibly expensive. So, I have a really critical question for you. Think about it. You've got tens of thousands of volts flying around, and a very, very expensive computer controlling the whole show. What is the absolute #1 thing you must avoid doing when you're testing for spark on a live engine? And here's the answer, and I want you to listen closely. The crucial point is this. You never, and I mean ever, ground a spark plug wire or a coil output directly to the engine block just to check for a spark. Why? Because that massive voltage has nowhere to go but backwards, right back through the system. And it can and will fry the ignition module or even the whole ECM in less than a second. So what do? You always use a proper spark tester. It's designed with the correct air gap for that spark to jump safely. It lets you see what you need to see without risking a catastrophic, and I mean multi-hundred, maybe even $1,000 failure. Always use the right tool for the job. And remember this old saying, it's all about not letting a small problem turn into a major one. Preventative maintenance is everything. You see, a simple misfire from, say, a worn-out spark plug might seem like a minor thing, but it leads to incomplete combustion. And where does that unburnt fuel go? It gets dumped right into the exhaust, where it can overheat and absolutely destroy a very, very expensive catalytic converter. All of a sudden, your $100 ignition problem just turned into a $1,000 exhaust problem. See what I mean? Okay, to wrap up this masterclass, let's have a little quiz. Let's put this knowledge to the test. Imagine this. A car rolls into your bay. It cranks over nice and strong, but you've confirmed there is 0 spark on any cylinder. So based on everything we've talked about today, what is your absolute first suspect? What is the very first sensor you're going to test? The answer, of course, is the crankshaft position sensor. Remember, if the ECM doesn't know the engine is turning, it's never going to command a spark. If you take one thing away from this, let it be that. Keep that right at the top of your diagnostic toolbox.